Hello, algebra students. Mr. Lawrence here, and this is a review video. I will probably split this video into two videos so that it doesn't take as long to stream. And also, that way, if you only need to watch the first part multiple times or the second part, or, it'll be easier to find. You won't have to, go through the whole thing. So if you have a slower internet connection than I do, it'll be a little bit more user-friendly for you. But it is going to be a long video. I'm not sure exactly how long. I'm guessing somewhere between 20 to 30 minutes because it's covering all the material that we've talked about for the test. Okay, so I strongly suggest you watch both videos and you watch parts of them more than once, and that's why I'm posting it early. Okay, so let's get down to this. First of all, we learned how to solve two-step equations. Okay, remember our goal is to get the variable alone. And we're going to listen to Saddam. He's going to tell us to undo subtraction and addition before we undo division and multiplication. So, the first one here, I'm going to subtract 5 from both sides. And remember, you must be showing work. I know that many of you are very smart, very intelligent, and you can just figure this out in your head. I don't have an equal sign in that equation. Sorry about that, ladies and gentlemen. This plus is supposed to be an equal sign. I must have hit the shift key or something by mistake. Anyway, so get back to the problem. We'll have a 1 there. X is still not alone. I'll need to divide by -3, divide by -3, and X is going to equal a -1/3. And there you go. And notice I don't need to go to my calculator. Why? There's no need to. Okay, on this one here, I got to undo the subtraction with addition. Oh, by the way, on that previous problem, if you're not sure why I subtracted 5 there, you should ask me about it in class as soon as possible. All right, the left-hand side is going to be x over 2, and the right-hand side is 5. Now I have a fraction, which implies division, and to undo division, I will use multiplication. I'm going to multiply by 2 over 1 on the left, and by plain old 2 on the right, because there's no fraction on the right. This will give me 10 on the right, and the easier side of this is that the 2's cancel out, leaving me with an x over 1, or just a plain old x. And there you go. My, we're looking awful colorful in our video today, aren't we? Okay. Now here we have one with variables on both sides. And I may stick another problem in here really quick. In fact, I'm going to go do the extra problem first. Let's say we had 5x minus 4, and that equals, I don't know, 3x plus 8. Okay, now remember, it bothers some of you that there are variables on both sides of this equation. We'll call this problem 3.5. Okay, so let's take one of them away. I usually like to take away the smaller one. And when I do that, I end up with 2x minus 4. X's cancel, and an 8. Well, now it's just a simple two-step equation. I'll add 4 to both sides, and I'll get 2x equals 12. And now we're down to a one-step equation. We'll divide by 2, and we'll get x equals 6, and there you go. Okay, let's get back to this. Hold on, I don't want that open. There we go. All right, so now I'm going to come back and do problem number 3. And I'm going to subtract 4x from one of the sides, and I have to do it to the other side. And the 4x's cancel, leaving me a 1. And the 4x's cancel, leaving me a -3. Okay, that should bug the bejeebers out of you. Yeah. Can 1 ever equal -3? No, it cannot. They are not equal to each other. There is no solution to this equation. There's none. You can't do it. You can never have a situation where 1 equals -3. So there is no x in the entire number line in all the real numbers that if I plug it in here and over here, I will get a true statement. Never. I'll always end up with a false statement like 1 equals -3 in that problem. Okay, now we have solving equations with quantities. And I know a lot of you on problem number 4, you're going to say, hey, let's distribute. And that's a darn good idea. So you're going to distribute here like this. Now don't forget to multiply by the 4. Some of you forget that. 2 times 3x, 6x. 2 times -4, -8. That's going to equal 10. And now it looks like a pretty simple two-step equation. I'll add 8 to both sides. And I will get 6x equals 18. And I'm going to divide by 6 on both sides. And x is going to equal 3. Okay, pretty easy. I know a slightly different way to do this one. I'm going to show you. And if you'd rather do it this new way, that is totally okay. But if you want to do it that way, that's a smart way to do it. This 2 is kind of in my way. If this 2 wasn't here and the quantity wasn't here, I'd be able to just have a two-step equation, right? And that's what distributing did for you. But because this 10 is divisible by 2, and this 2 is attached to the quantity by multiplication, if I wanted to, I could divide both sides by 2. The 2's would cancel, leaving me with a 3x minus 4, and then a 5. And now I have the two-step equation I was talking about. I'll add 4 to both sides. I'll add 4. And then I will get 3x equal to 9. And I will divide by 3. And divide by 3. And x is going to equal 3. And notice I got the same exact answer. It's good to have a multiple of different techniques, multiples of different techniques. A multitude of different techniques. There we go. I knew that didn't sound right. In your bag of tricks to solve equations, because some situations it would definitely be smarter to distribute, and in some situations it would be awfully easier to divide or perhaps multiply in some situations and get rid of certain things and then solve the equation. Okay, let's go on to problem 5. This is not one where I would consider doing it like I just did problem 4. I'm definitely going to distribute on this one. I'll multiply the first quantity by -3. I'm going to multiply the members of the second quantity by +4. And so when I do that, I'm going to get a -6x plus 15. And on the right-hand side, I'm going to get a 20 minus 12x. Now again, we've got variables on both sides. Well, I'm going to take one of them away. And remember, my advice to you was to take away the smaller coefficient, the variable with the smaller coefficient. Well, the smaller one would be -12. And to take away a negative, I'm going to use addition, right? And my left-hand side is going to turn into 6x. -6x plus 12x is +6x plus 15. And that's going to equal 20. And then I'm going to subtract 15 from both sides. And that will get me 6x, which is going to equal 5. I'll divide by 6. And then I will get that x is going to equal 5/6. And remember, fractions are our friends. It's okay to have a fraction. All right, number 6. If I wanted to, I could do the division thing. I'm not going to demonstrate it, but I could divide both sides by 2. Just remember, if you do that, you'll have to divide here and here by 2. I'm going to go ahead doing it using distribution, but if you're comfortable with the division, you go ahead. multiply, distribute the 2, and I'll get 2x minus 12, and that's going to equal negative 12 plus 6x. All right. I think I'm going to subtract 2x from each side. And the left-hand side will get me negative 12. The right-hand side will get me negative 12 plus 4x. I'm going to add 12 to both sides, right? Just listening to Saddam, getting rid of the subtraction first. The left-hand side will turn to 0. The right-hand side will be 4x. I'll divide both sides by 4. Then x will equal 0. And there we go. Now, what would have happened if I would have had a situation like this? Okay, let's say I have 2 times the quantity of x minus 6, and that's going to equal negative 12 plus 2x. Well, I do my distribution, right? And I'm going to get 2x minus 12, and that's going to equal negative 12 plus 2x. I don't like variables on both sides, so I'm going to subtract off a 2x, and then I subtract off a 2x here. Now, some of you are anticipating an answer, but you're anticipating the wrong answer. Pay attention to this. I've got negative 12 equals negative 12. Does that bother you? Well, it might bother you that the variable dropped out of the equation, but the fact that you got a true statement, negative 12 does equal negative 12, right? It's the same number, and it always equals negative 12. This situation is where all real numbers work. Any number for x that you plug in both, you have to plug it in 2 places. You plug it in both here and here will result in a true statement. You have to plug the same number in because it's the same variable. For example, if I plug a 10 in, all right, here, if I put 10 in right here, on the left-hand side, I'm going to get 10 minus 6, which is 4. 4 times 2 is 8. Okay? Over here, I'll have negative 12 plus 2 times 10. Well, that's 20. Negative 12 plus 20, that's positive 8. There you go. Any number you pick. You could put pi in there. You could put the square root of 37 in there. Any number like that. Okay, I'll give you a sneak peek of what the next video is going to have. Solving equations with fractions. Combining like terms. Solving literal equations. And translating and solving equations and inequalities. I'm going to stop this video here. It's only 13 minutes long. So I will say good night, everybody. But you can watch part 2. It'll be posted the same day.